Hey everyone, welcome to this video. We are going to talk about tensors. So PyTorch uses tensors. Tensors are a way of storing numbers. And tensors are optimal for the math used in deep learning, in case you were wondering why we should care about learning about tensors. So a zero-dimensional tensor slash rank 0 tensor, also called a scalar, is just a single number. In this case, the number 101. A one-dimensional tensor slash rank 1 tensor slash vector is an array of numbers. Imagine we have an animal shelter. This array of numbers could represent a single dog that's 3 years old, has a height of 61 centimeters, and a breed of 1, which could be for a Chihuahua. We can access a number in an array using one index. To access the number 61 here, we need to use an index of 1, and shape returns one number back, which is the number of features. So when I do a print x.shape, the number of features is 3, age, height, and breed. And because we need one index and shape returns one number back, that's why this is a one-dimensional tensor or a rank 1 tensor. Now let's talk about a two-dimensional tensor slash rank 2 tensor, also called a matrix. It's an array of arrays of numbers. Now in our animal shelter, we can represent 3 different dogs. Like this second dog is 2 years old, has a height of 55 centimeters or inches, use your imagination, and it has a breed of 3, which could be a pug. We can access a number in a matrix using 2 indexes or indices, and to prove this point, I'll copy this matrix over to a Python file, and to access the number 55, we have 3 subarrays. 55 is in the second subarray, which we can access at index 1. And within this subarray, 55 is also at index 1. So I use 2 indexes or 2 indices. If I do a Python scratch.py, I get 55 back as expected. So again, this is to prove the point that you need 2 indexes, as mentioned here. Shape returns 2 numbers back, rows and features. So I do a print x.shape. There's 3 rows for 3 different dogs, and there's 3 features, age, height, and breed. A 3-dimensional tensor slash rank 3 tensor can also be called a cube, and it's an array of matrices. An intuitive example of this is a color image with 3 matrices, red, green, and blue. In fact, earlier on in this course, when we ran the fcffnn.ipynb file, I did a print single image, and here's the dot shape. I get 3 numbers back because we are working with a 3-dimensional tensor. But the images we worked with were not in color, so this is not going to be 3 for red, green, blue. It's just going to be a 1. And the images were 28 pixels by 28 pixels. We can access a number in a 3-dimensional tensor using 3 indexes, and shape returns 3 numbers back, color channels, height, and width. A 4-dimensional tensor slash rank 4 tensor is an array of 3-dimensional tensors. Examples could be a batch of images or one video with many frames. So here, this could be a batch of 3 images or one video with 3 frames. We can access a number in a 4-dimensional tensor using 4 indexes. Shape returns 4 numbers back. Example could be the image batch size, the color channels, height, and width, or the number of frames, color channels, height, and width. Last one I want to discuss in this video is a 5-dimensional tensor slash rank 5 tensor. It's an array of 4-dimensional tensors. example could be a batch of videos. In this picture, this is a batch of 3 videos. We can access a number in a 5-dimensional tensor using 5 indexes. Shape returns 5 numbers back. An example could be video batch size, frames, color channels, height, and width. So yeah, 1, 2, 3, 4, 5. And here is a table summarizing everything I've gone over in this video. What I want you to focus on is this examples. So a 1-dimensional tensor could represent a single dog in your animal shelter. A 2-dimensional tensor could represent multiple dogs in your shelter for your data. A 3-dimensional tensor can represent an image in your data, as we saw here. A 4-dimensional tensor can represent a batch of images or a video in your data. And a 5-dimensional tensor can represent a batch of videos in your data. All right, that's it for this video. Thanks for watching.